Explain the strategy design pattern. The strategy pattern is a behavioral design pattern that helps you define multiple algorithms or multiple ways of doing the same task and lets the client choose which one to use at runtime. In simple words, strategy lets you change the behavior of an object without modifying the object itself. You simply plug in a different strategy and the behavior changes instantly. Instead of writing long if-else conditions or switch statements to decide which algorithm to run, strategy moves each algorithm into its own class. Let's understand this pattern with a simple diagram. The diagram shows three key parts: the client, the context, and the strategies, strategy A, B, and C. The client wants to perform an operation but does not want to hard code which algorithm should run. The client passes control to the context, which acts as a middle layer. The context doesn't implement any algorithm itself. Instead, it receives a strategy and delegates the work to that strategy. On the right side, you see multiple strategies like strategy A, strategy B, strategy C. Each strategy represents a different way of performing the same task. By plugging in a different strategy, the behavior of the context changes instantly without modifying the context or the client. This removes long if-else conditions and keeps your code flexible and easy to extend. Now let's understand this pattern with a very clear and practical demonstration that you can explain confidently in any interview. We will build a payment system where the user can pay using different payment strategies: credit card, UPI, or PayPal. Using strategy, we can switch the payment method at runtime without changing the main program logic. Here is the complete example. We begin by creating an interface called payment strategy. This interface contains a single method named pay that accepts an amount. Each payment method will implement this interface and provide its own version of how the payment should be processed. Next, we create three strategy classes: credit card payment, UPI payment, and PayPal payment. Each class overrides the pay method and prints how the amount was paid. Now comes the main component that uses these strategies, the shopping cart class. Shopping cart has a field named strategy that holds the current payment method. We inject a strategy through the constructor and also provide a set strategy method so that we can change the strategy at runtime. Inside the checkout method, we simply call strategy.pay and pass the amount. The shopping cart does not know which strategy is being used. It only knows that a payment strategy exists and that this strategy will handle the payment. Now let's walk through the main method. We create a shopping cart object and pass a new credit card payment strategy. This means the first checkout call will use the credit card algorithm. So the output becomes paid 500 using credit card. Next, we switch the strategy by calling setStrategy and passing a new UPI payment object. Now the payment method changes dynamically at runtime. When we call checkout again, the cart uses the new strategy and prints paid 400 using UPI. Finally, we switch to PayPal payment and call checkout again. This time the output becomes paid 300 using PayPal. Let's run the program. You can see the output. The payment is done by using credit card, UPI, and PayPal. This demonstration clearly shows the core value of the strategy pattern. You can switch behavior simply by changing the strategy object without changing the class that uses the behavior. In this example, you can change the payment method at the runtime. The shopping cart stays clean, stable, and reusable. All variations are isolated inside their own classes. Now let's see. When should you use the strategy pattern? Use the strategy pattern when you need different algorithms for the same task. For example, different sorting algorithms, different payment methods, different validation rules, different compression formats, or different discount calculations. Use it when you want to avoid big switch statements or too many if-else blocks. Use it when you want to change behavior dynamically at runtime. Use it when your code needs to follow the open-closed principle, open for extension but closed for modification. Next, why is strategy important? The strategy pattern keeps your code flexible. New strategies can be added without modifying existing logic. It promotes loose coupling. The main class delegates work to a strategy, not caring about the exact implementation. It improves testability. Each strategy can be tested independently. It keeps the system clean because every algorithm lives in its own class instead of being mixed inside a long chain of if-else conditions. In real-world software, strategy is used in payment gateways, authentication modules, validation frameworks, sorting and searching algorithms, discount calculators, and even routing logic. Here is the short interview answer you can say in the interview. The strategy design pattern is a behavioral pattern that allows you to define multiple algorithms and switch between them at runtime without modifying the code that uses them. It encapsulates each algorithm inside its own class and makes the system flexible, maintainable, and easy to extend. That is the complete explanation of the strategy design pattern.